Good day, everyone. So today I want to share a neat algebra trick that is called completing a square. It might sound fancy, but it's really just a way to turn any quadratic expression into something that you can recognize. And that is a perfect square plus something a little extra on the side. So when completing a square, the goal is to regroup terms so that most of them becomes a perfect square. So a perfect square is something that is in this form. X plus d squared. So the little chunks in your equation are the constants, or is the constant that comes up after this perfect square. So you will have chunks on the side, so you can just say chunks. So the chunks on the side, it's just a constant coming after the perfect square. So after completing a square, you will have an equation that looks like, for example, ax plus d squared and then plus q, where q is what you call a chunk, your chunk or your constant. So I'm only saying a chunk now so that you can remember it that way. So now I brought up an example with variables. I know a lot of students don't like variables in their equations, but then I'm doing this so that I can solidify your understanding, so that you can see the general procedure of solving equations. What I normally tell people to do when they have to complete a square is that they need to identify the terms in their expression or an equation that have a variable x or x squared attached to them. So in our equation, ax squared is our first term that has a variable x squared, and bx is our second term that has a variable x attached to it. So after that step, what you should do is to put all the terms that have a variable x squared and x attached to them into a square bracket. So by doing that, you will get something like ax squared plus bx. You put it inside the square bracket and you leave the constant out, because putting this constant inside your square bracket, it might complicate your life a little bit. So after that step, what you need to do is to factor a out. So if you factor a out, remember it will only affect whatever that is inside your square bracket and not what is outside your square bracket. So by factoring your a out, you will get that a is x squared plus b over ax, and then you still get your constant c out. So this step is the step that you normally do when your a is not equal to 1, meaning that the coefficient of x squared is not equal to 1. So this is the step that you should do. I mean, you can also do it if you have the coefficient of x squared being 1, so that maybe you sort of see the procedure well. So after factoring the a out, your next goal is to convert whatever that is inside the square bracket into a perfect square. So for you to convert it into a perfect square, you sort of need to add 0. But the 0 that you are adding, it's a special 0. It's not just the 0 that you are used to. So that special 0 that you're talking about, it's that you're going to have x squared plus b over a x, and then you add half of the coefficient of x. So the coefficient of x, it's the coefficient of x that is inside your square bracket. So you're going to have half of b over a, and then you square that, right? And then you subtract again. You subtract the very same term, which is minus open bracket half multiply by b over a, and then you square it, and then now you close your square bracket and you add your constant out. The next step that is left after doing the previous step is that you need to convert most of your parts or most of your terms in the quadratic expression into a perfect square. Remember, that is the goal of completing a square. You need to have a perfect square. If you don't have a perfect square, that means you didn't complete a square. So what you have to do now is to get rid of these square brackets. So getting rid of these square brackets, we are going to do it in a special manner. So the way in which we're going to do it is we check the first 3 terms of what's inside our square bracket, and then we put them together. So by putting them together, I mean taking them inside one bracket. So we take them inside one bracket, and whatever that is out, it's a separate term on its own. So now we are going to multiply this a by this, by the red brackets. So we don't do the multiplication individually, we just write it as a whole. So it's a, and then we have x squared plus b over a x plus, and then your half multiply by b over a squared, and then now you have subtract a into half multiply by b over a squared plus c. So now what you do, sorry, I left out the bracket here. So now what you do is you have to simplify this bracket, and when you simplify it, you have ax squared plus b over ax plus, and then this half of b over a, it's just b over 2a, and then squared, and then minus your bracket, so it's b over 2a squared plus c. And now you need to factorize this. So if you factorize it, it's just easy. You just say a, and then you open bracket, you say x. After this, you take the term that is inside your bracket squared. So that term that is inside your bracket squared, you take it as is, and then you can see that it's a positive term, so that means it will be plus b over 2a, and then you square all of that, and then you subtract whatever that is outside your bigger bracket, and that is a over a open bracket b over 2a squared plus c. So after this step, you have basically completed a square. So if you want to simplify it further, you might get something like a x plus b over 2a squared minus, and then you'll have a multiplied by b squared over 2a squared, and then plus c, and then this a will cancel this a, one of the a's in your a squared, and your final solution will be a x plus b over 2a squared minus b squared over 2a plus c. Sorry, 2a plus c. I don't know why it doesn't want to write. So this is your 2a. So this is how your final solution should look like in terms of variables. So you can see how messy it is, but then once you have numbers into your equation, you do the similar thing. You don't do anything that is completely different from this, you just do the same thing. So I'm going to show you an example whereby now you do this following the very same steps using equations or an expression that has. So this is our little example of completing a square. We are going to follow the very same steps that we followed in the previous explanations. So like I said, the first step is to identify the terms which have a variable x squared and x attached to them, and then after that you put square brackets around those terms, and then you isolate your constant. You don't put your constant inside your square bracket. So the first step, identification, you can see that it's x squared, and then you have plus 6x. So those are the terms that have x squared and x attached to them respectively. So after doing that, you box them, sorry for that, and then boxing, it's just x squared plus 6x, putting a square bracket around them, sorry, and then you take the constant out. So remember that I told you that you check the coefficient of x squared, you factor it out. So in our case now, the coefficient of x squared is 1. So you can do that for the sake of your own understanding, but then if you have the constant of the coefficient, sorry, of x squared being equal to 1, you really don't need to do the step. But then for the sake of everyone's understanding, we are going to do it. So you take 1 out, which is the coefficient of x squared, you factor it out, and now you'll be left with x squared plus 6x, and then you close your square bracket, and then you add 5 to that. Sorry. And then after doing that step, remember I told you that your goal is to add a special 0 inside your square bracket so that you can convert it into a perfect square. So what you do is you write the factor that you took out, which is 1 in our case now, and then you have x squared plus 6x, and then the 0 that you are adding is you open bracket, the half of the coefficient of x. You take it as is. If it's negative, you write it as it is. If it's positive, you write it as is. So in our case, it's positive 6. So you'll just say multiply by 6, and then you square that, and then you subtract again that term that you added. So, because remember, you are adding a 0, and that 0, it's a special one, and it's this 0. So it's your half multiplied by 6 squared. The reason why we're doing this step is because we don't want to change our original equation. If we just add half of 6 squared, we have completely changed the equation. So we need to subtract that term so that we keep our equation in its original form. When we have to multiply it out, we get it in its original form. And then now you close your square bracket, and then you add 5 to that. So remember that I told you need to check to sort of put brackets around your first 3 terms inside your square brackets, and the first 3 terms in our case, it's x squared plus 6x, and then plus open bracket half of 6 squared. So after grouping them out, you basically just put a big bracket around them. So I'm so sorry, let me use a different color. You just put a bracket around them, and then after that you multiply in this term that is in front of your square bracket, and then you multiply it by the bracket, by whatever that is inside your bracket. You don't multiply it individually, you just put it right in front of your bracket, and you do the same thing. You multiply it to this term here that is not inside your bracket of the first 3 terms that are inside your square bracket. So by doing that, it will be 1, and then you multiply it by x squared plus 6x, and then plus. So inside your square bracket, you have half of 6, which is just positive 3 squared, and then you close your bracket, and then you subtract, and then you multiply this 1 again into this term over here, and then you have minus 1 multiplied by half multiplied by 6 squared, and then you add 5. So basically this step is you're trying to get rid of everything that is inside your square bracket, but you get rid of it in a special manner. So after that, now what you get is basically x squared plus 6x plus 3 squared. Don't try to simplify this. You'll see there's a reason why I'm not simplifying this 3 squared and writing it as 9. So it's minus, and then you'll have 3 squared plus 5. So after this step, you just open your bracket. You don't have anything in front of this bracket. It's basically 1. So if there was something, you are just gonna write it out. So in our case, it's just 1. So you can just say that 1 that's in front, and then you open bracket, you write x, and then the term that you're going to write, it's the term that's inside that bracket that is squared. So you write that term as is. If it's negative, you're going to say minus 3. If it's positive, you write positive 3. So in our case, inside that bracket that is squared, it's positive 3. So it's plus 3, and then you square it, and then you solve what is outside your bracket. Sorry for writing that out. So you'll have negative 3 squared plus 5, and then that is negative 4. Sorry, it's negative 4. So you have completed your square in a nice and neat manner. So this is the general procedure that you have to follow when completing a square. From me, your buddy, I'm saying thank you for watching this video. If you got to this point of the video, I hope you understood the general procedure of completing a square, and I didn't confuse you more. I really appreciate it.